first studies demonstrating the involvement of endothelin in kidney diseases were performed in the Mario Negri Institute. When and how did you discover that?
Our group, with Professor Remuzzi as a mentor, started in the early 80s in finding new mediators of renal disease progression. And we obtained very nice data as far as angiotensin 2, and then with the help of ACE inhibitors we were able to retard renal disease progression, but not in all patients. So we were looking at new mediators of renal disease progression, and at the end of the 80s, endothelin was discovered by Masashi Yanagisawa. So we thought that this could be another mediator of renal disease progression. First of all, we demonstrated that actually it was increased during the progression of renal disease, either the messenger RNA and protein, and then we took advantage by the availability of a receptor antagonist for the ATA receptor that was very helpful in retarding renal disease progression. It reduced blood pressure, and as a consequence also it reduced proteinuria, but a striking effect was on the renal structural damage that was quite completely normalized, restored to normal levels by the receptor antagonist specific for the ETA receptor.
What's the mechanism underlying the protective effect of endothelin receptor antagonist in kidney diseases?
The renoprotective mechanism of inhibiting endothelin-1 in the kidney is manifold. First of all, the endothelin receptor antagonist reduce blood pressure, and this is also accompanied by reduction of proteinuria because of the reduction of intraglomerular capillary pressure. Reducing proteinuria is beneficial for the proximal tubule because the resorption that the proximal tubule engages during the disease induces the alteration of the cell phenotype, which becomes a pro-inflammatory cells and start to increase the synthesis, the endogenous synthesis of endothelin, which is released into the interstitium, and in this area it creates inflammation. The exaggerated tubular expression of endothelin is also capable to induce the accumulation of matrix by interstitial fibroblasts and concur to the tubulointerstitial damage. But there are also data showing that endothelin has a role in the glomerulus, and particularly in podocytes, in cells that are important for the integrity of the filtration barrier, and podocytes are lost during the disease progression. So endothelin favors the migration of these podocytes. So inhibiting endothelin also at podocyte level reduces the loss of podocytes that accompanies the progression of renal disease. So there is a benefit either at the tubular compartment as well as at the glomerular area.